Hey everybody, welcome to Textbook Thursday. So I'm Adam Sawyer. I'm a senior technical support engineer in the Raleigh office of Qlik. Primarily I work with Qlik infrastructure integrations, so integrations of things like mashups or data integrations, things like that, and cloud architecture, which is what we're going to be talking about today. And I started at Qlik a little over 2 years ago. So an agenda for today, just a very brief introduction to Qlik Enterprise on Kubernetes. We're going to talk about some of the minimal technical prerequisites. I'm going to show you guys just a quick deployment demo that I got up. We're going to talk about considerations for your proof of concept or production instances, just things to think about as an organization. And then I'm going to share some brief resources at the end. Maybe this is your first time hearing about this product or you know a little bit about it, but primarily Qlik Enterprise on Kubernetes is a scalable microservices analytics platform. It's built on top of Kubernetes, an orchestration layer for containers. It uses Docker containers. Because it can run off of Docker containers and Kubernetes, you can run it on Linux hosts, which will get you a better total cost of ownership because you'll be able to use resources a little bit more effectively. And it works with multiple infrastructure as a service or public cloud providers, from AWS to Google Cloud to Microsoft Azure, which we're going to be showing off today, to Red Hat OpenShift. This stack is fairly modern as well. And the biggest thing is when we talk about scalable microservices, that's going to be the real advantage of Qlik Enterprise on Kubernetes. So the way that looks is, if you take this slide, you have the new Cloud Hub that we're all sort of used to, along with the new Cloud Console. So these are the hub and console that are shared across all the different cloud editions. So that can be Qlik Enterprise on Kubernetes, that can be Qlik Enterprise on Cloud Services. That's also our new offering of Qlik for Business. Under the hood of that, though, are just a series of different pods or containers in Kubernetes. Each one of these scope to a specific service. So you have services that run client and content. You have services that handle identity management and authentication and authorization, right? You have policy and security pods that allow for encryption and system event auditing. You have pods to handle the data. Then you have the Qlik associative engine running in pods, right? That's really one of the big advantages, is this is its own individual class in Kubernetes, and you can take advantage of specifying what you want those engines to do. And then there are just other pods that are there for ancillary systems, right? So licensing to make sure that your instance is properly licensed, job scheduling, and then we have ingress and other NoSQL databases to help with that. And so undergirding that is MongoDB, so a document store to handle some of the metadata of the system. Then you have just normal data volumes, which are just mounts, but we'll get into that a little bit later. And then you do need a modern identity provider along with it. So what I'm going to be covering in this section are the minimum technical prerequisites. The first thing you need is an access type sign license. So with that, these are delivered through JOT. So if you've used Qlik before, you know that there used to be like a serial number, control number kind of schema, right? Well, with the addition of analyzer capacity, where we're tracking how much your analyzer tokens are using the product, we needed a way to check that. So the sign licenses help. So it's basically a JavaScript web token section of text. You post that into the console. It's required for all editions of Qlik Enterprise, or at least the cloud editions. It also requires internet access. Additionally, though, you need a working Kubernetes environment with that internet access, right? If you're just doing evaluation and testing, you're a developer and you want to see what some of the new Cloud Hub looks like, we do have support for basically a miniaturized Kubernetes environment. So that's Minikube or Red Hat's Minishift. There are some version requirements, making sure that Minikube is over 0.33 and that Minishift is 1.21. For other use cases, maybe now you want to see if you can build a UAT environment. So the only real requirement we have there is that Kubernetes 1.11, and that would allow you to run on all of the different cloud providers. You're also going to need to interact with the environment. So that requires a local tool chain. Qlik Enterprise on Kubernetes requires access to a couple local tools. So one is kubectl and Helm. Both of these are tools that allow you to interact with the services of Kubernetes in different ways. One of the things you'll have to do is make sure that you're pointed to the right Kubernetes cluster. And so what you'll see here are just some sort of basic commands for pulling the requirements for these two different products. What this allows you to do is it allows you to control the Kubernetes cluster manager. So it's a command line for the Kubernetes cluster. It connects to the primary node in an available cluster. Your kubectl version should just be one minor version different. So if you have a cluster that's like 1.13 of Kubernetes, then you can use kubectl 12 through 14. You may have noticed I called this kubectl or kubectl. There is a little bit of disagreement about what that actually looks like or sounds like. These are all some of the different variations of what you could call it. So some people call it kubectl, some people call it kubectl. What I like to do is just alias it on my local box where k equals kubectl at. So with that, we also have Helm. So what Helm is it's a package manager for Kubernetes. What it does is it uses charts. The supported versions are 2.12. I think the most recent release that we support is 12.14.3. What it's going to allow you to do is create and delete and upgrade what are called deployments. While kubectl can allow you to set up a Kubernetes environment manually, right, using the command line, what Helm allows you to do is in a declarative fashion change or modify an existing Kubernetes product. So Helm is actually the way that Qlik Enterprise on Kubernetes is delivered to the Kubernetes environment. So there are some helpful features with this because it is declarative. It makes GitOps possible. So that means that you can have a single source of what your files ought to look like. Additionally, you can map complex environments this way. Because it's declarative, it means that you're going to have a single source of truth, and then it allows you to have same or similar configuration between environments. So what this looks like is this example here. So you have a values.yaml file. That's kind of the generic name for a Helm chart. It contains settings of the configuration that are specific to your instance. What that then does is Helm interprets that. It passes it to a tiller pod, which is basically just the service pod running with role-based access control inside of the Kubernetes cluster. That tiller pod can talk to the Kubernetes API service, which will then do the work of creating the things that have been declared in the Helm chart and in the configuration file. So Helm uses this tiller service with root permission. But the advantage of it is that it allows you to roll back and to apply the same configuration from the same product to different environments. Qlik Enterprise on Kubernetes requires OpenID Connect supported IDPs. And so what that looks like is you'll have a user source. This user source will just be a user that you'll have the product of Qlik Enterprise set up, possibly with another stand-in IDP, just so you can get access to it, along with the other additions of Qlik Enterprise. You have an IDP that connects to this user source, and then maybe it's the same IDP that's used in Qlik Enterprise for Windows, so then those are going to integrate through OIDC. Another requirement, Qlik Enterprise on Kubernetes does leverage groups, and right now Azure AD does not support groups, so just be aware of that. So let's say you're in the scenario where you have Active Directory as your user source on Qlik Sense Enterprise for Windows, right? You have an IDP that you've set up in kind of isolation. Maybe you didn't do the work of setting up the user source, right? So what that can look like is the values that you have in the IDP don't necessarily match. So one of the advantages of Qlik Sense Enterprise is the shared license between different versions of Qlik Sense, which we'll be able to show off today. But if the IDP hasn't been set up to match those versions, one of the things that will happen is that when that IDP connects to the access sign token, or license rather, in Qlik Sense Enterprise for Kubernetes, you'll see where you've consumed 2 licenses through that. So just be aware that you need to think through not just the modern IDP architecture, but making sure that the IDP is sending the right things for the licensed users you have, right? So then you have storage, right? In Qlik Sense Enterprise for Kubernetes and in Kubernetes more generally, we leverage the Kubernetes platform to handle storage classes and volume claims. So what that allows us to do is it allows us to create an abstraction layer between the physical hardware that's maybe in a particular cloud environment like Microsoft Azure, and set that up so that it's dynamically creating the volume claim for Kubernetes. It has to support read-write many. So what read-write many is it allows a specific volume in the Kubernetes environment to be mounted to many pods, right? So the way that Qlik Sense Enterprise on Kubernetes leverages storage is that all of these pods are talking to one set of storage. This is persistent storage, right? So this is not storage that's being located in a pod. This is storage that is being mounted to a storage class in your infrastructure. Because of that, it's a storage class, you can have different configurations that are set for the Qlik Sense Enterprise on Kubernetes environment. So you can set things up like quality of service, you can set up backup routines. Additionally, these storage claims can be treated the same as the volume claims in the Kubernetes environment. And different storage classes can scope to different providers. So in the example we're going to show you today, we're going to use Azure. And so the way this looks is something like this. This is taken from the Microsoft Docs. But basically, Azure Files is the storage class within the Microsoft Azure environment. This is scoping to a persistence volume claim inside the Kubernetes environment. So maybe a generic of this would be like network file storage or NFS. Persistent volume claims can dynamically provision persistent volumes, yeah. And then pods treat these claims as volumes. So for Kubernetes, the claim is what the pod is going to know as a layer of abstraction on top of the physical storage. That's why the access mode has to be set, is because if multiple pods can't connect to the same storage, Qlik Sense Enterprise on Kubernetes won't be able to write files. Let's go ahead and move into the demo inside the Microsoft Azure Public Cloud. Well, the first thing is I'm using PowerShell. This is PowerShell version 5. That doesn't matter, just so long as you can set up the kubectl and the Helm command. So if you look here, we can do kubectl get pods. So this is the working instance of Qlik Sense Enterprise on Kubernetes that I've already set up prior to this meeting, right? But one of the things I can do is I can also look at the Helm, right? So if I go back through my history, I can see the persistent volume claims that I have. So I have this set up with Azure File, and then I can also see the services that I have. So these are going to scope to the services that are provided by each of the pods, right? And so you can see the different ports. So obviously, I don't remember the commands right offhand to go do this, but what I have done, I just created a really quick YAML file or a README that's actually publicly available on my GitHub. github.com, AW Sawyer, QSEOK support templates, and then it's just the master branch and then Azure. And what this has is all of the commands that I'm running to bring out this environment, right? So some of the commands that I ran were the Helm repo. So this actually pulled down the Helm repo. Then I installed Qlik, Sense, and Knit. What this is it's just a chart that allows the engine to be initialized prior to the installation of Qlik, Sense Enterprise on Kubernetes. And then what I did was I deployed from a local YAML file on my local laptop using Helm, right? And then the product installed. And once that was done, what it allowed me to do is I would see all of these different resources inside of Azure. Additionally, I could also check for these resources inside of my PowerShell, right? I now have a working QSEOK environment. So let me get out of this stale session really quick and just go to Elastic example. So the way that I'm getting to this is, if you noticed, I had a public IP address that was acceptable here, right? So this address right here. And then what I did was I went into the host file of my local machine. I'm going to open that with VS Code. Oh, there it is. And we can see right there where that was added to my host file. Obviously, when you get beyond a proof of concept, you're going to want to set up DNS and other things. Additionally, this doesn't have TLS enabled, but my script in the Kubernetes environment does have a section specifically for TLS. So if we head over here to the YAML, and we go to QSEOK values, which is sort of the generic file, right? You'll see the configuration in a YAML file. So YAML is just a format that is the actual declarative for this environment. So walking through that, we have that dev mode's enabled. This kind of speaks to the MongoDB database and how security is enabled. We've accepted the EULA for the engine class. We have my IDP, right, where my specific instances are. Now this is actually modified, so it's not my real client secret, so don't worry. I changed all these characters to be custom characters. But then we also have the ingress pod. So the ingress pod is the pod that scopes to this specific IP, so it's the ingress controller. And so what I can do is actually go to kubectl, describe pod, and then let's, I'll have to get pods real quick. Control get pods, just so I can get the specific pod number, because you will notice that there are appendages. If you're in Bash, you can actually pipe that out just so that you get the right name. But in PowerShell, that's a little bit more complicated syntax, so we're not going to do that today. But kubectl, describe pod. And so here are the actual configuration of this pod, right? So we can see that it's running the release QSEOK, which is my Helm deployment. We can see that it has a private IP address. And then we're also going to be able to see a public IP address. So let me scroll down. Where did I put it? So here's the pod, and then talkable. Yeah. So when we go to get services, which I've already shown you guys, you're going to see that this service has been given this load balancer. We'll talk a little bit more about load balancing in QSEOK, but the other thing is I do have a connection to that Azure storage class here. And then I have the MongoDB database along with what kind of rights it's going to have and what storage it's going to have. And those are specific to the MongoDB item. So if we head over here, The configured IDP is auth0. You can also set it up with Okta. You can see that I have a couple of different tests. So this is already licensed. So the first time you log in, you'll see a little banner here that says you need to license the software. So the way you can do that is actually just go into the management console by going to /console. If you're a tenant admin, which you'll have already set up, which I am here, you can get in here and make edits, right? If not, you're not going to be able to see anything necessarily. But you'll see, I won't go to it, but here's where you can set the license key. It'll be the first thing that pops up. And so you would just basically copy in your JOT that you were using for your signed access license, right? So one of the cool features of Qlik Enterprise on Kubernetes is the spaces. So you can create manually shared or managed spaces. Shared spaces are a space where it's a little bit less governed. People can work on different apps and make edits, right? But a managed space is what we would think much more in Qlik Enterprise for Windows as a stream, right? So we'll just create this one and call it managed. There we go. So then as we go out to the hub, we're licensed, we have a successful user, we have a modern IDP, all the other prerequisites are there. It's the same Qlik that everyone knows, right? We can go to the script editor and then just load data. If you're interested in setting up this environment, one of our architects made a video of him walking through the deployment. It's a great resource. It's going to be in those links. That's something that you should really look at if you want to set up an environment like this, right? So now we can just switch over to analysis, and it's just the same hub that it always is. Just add a chart. We'll just add a really big bar chart. There you go. And so one of the things you might want to be considerate of as you start doing work in the hub, not all extensions and themes are approved for Qlik Enterprise on Kubernetes. Let developers know that maybe a relative path or something else in an extension is having issues. So that's kind of Qlik Enterprise on Kubernetes. I would say definitely give this a try. So let's jump back into the PowerPoint. So as you prepare to do this testing, you have the minimum technical prerequisites, right? There are some other considerations that you're going to have to make with regard to moving forward with Qlik Enterprise on Kubernetes, right? So with regard to administration for this environment is different than Qlik Enterprise for Windows and other more traditional BI platforms, right? And the reason for that is because we are leveraging a lot of what Kubernetes can provide in terms of scalability, high availability, but that also comes with changes in paradigm and thinking, right? Even for Kubernetes admins, this is going to be a place where they need to understand what the Qlik tool does, specifically with persistent data and stateful pods, and also the MongoDB database, right? The Kubernetes world is really just different in Windows. As I've mentioned, there are these declarative YAML files that provide configuration that can be done on the fly, which is great, but that's a really different way of thinking of a stateful Windows server, right? Where you have an instance and then you install an application on it and you have to keep that application. In Kubernetes, you can redo the environment really quickly, but you also have to understand the underlying pieces of Kubernetes architecture to get that benefit, right? So there are trade-offs. Additionally, pods are transient resources, right? In any environment, pods will fail, and that's okay. They're meant to be multiplicative. They're meant to be across different instances, and so the fact that these are transient resources is all right. But what that does mean is that you need to plan for it. That's also true for high availability and high distribution, right? Like one of the benefits you're hoping to get is scale. The ability to scale out quickly, the ability to run more engine instances at a lower total cost of ownership, right? But what that means is that you have to plan for high availability. A modern IDP, MongoDB. There are other resources we're going to talk about just in a bit, but that aren't necessarily part of the product, but are part of the Kubernetes ecosystem. So the thing that I like to say is that QSEOK is just deeply dependent on Kubernetes systems. So that means that you have to change from thinking about these static systems to thinking about dynamic processes. While there is intrinsic autoscaling inside of Kubernetes, right? So this would be kind of the example in AWS of you can set up 4 EC2 instances, make one of them the master and make 3 of them the nodes, or you can use EKS cluster autoscaling, right? We recommend cluster autoscaling over maybe CPU-based autoscalers. You're going to want the Kubernetes instance to know what the resources are on these different machines and be able to bring them down or bring them up gracefully, right? Cluster autoscaling will not schedule by default best effort priority pod. So by default, Qlik Sense Enterprise on Kubernetes sets all of the pods to be best effort. So thus it will require testing and confirmation to make sure that the pods that are key to your business's strategies are beyond best effort and have resource and request limits that are associated with not being a best effort priority pod. A best effort pod, you don't have to set resources and requests and limits, but Kubernetes doesn't try to make sure that those are saved, or that if a resource starts getting used to a greater degree, that it should then bring up other resources, right? So you've got to set limits before it'll know, okay, this is what, and that depends on your use case. So you can use a horizontal pod autoscaler, but you will need to set a quality of service with that. In addition to sort of autoscaling conversations where you can derive a lot of benefit, there are simpler ways to do scaling. And that's just the number of pods that are running a particular service, right? These are actually, increasing the replica count of how many pods are tied to that particular service or pod, right? And so what we generally say is, if you're just setting this up for the first time, in the example I showed you, we only have one replica set, right? But as you begin to think about moving this into UAT, or you'll need to increase the number of replicas that are out there for your users, right? But there are other kinds of scaling details too. But these are all things you should be aware of before you start trying to put production load in a scaling environment, right? So the other thing is with automation of deployment, this is largely up to your organization. If you consider making a Git repo your source of truth, so the YAML files that I've created, eventually those will be really highly customized to your deployments. And you want to make sure you have a place that you can say is, this is the deployment for this kind of environment, right? And because it's declarative, you can do that. It's all of the configurations are in those files. But ultimately, the ideal scenario is going to be that if you change the YAML file, you change the environment. That's kind of the goal of the kinds of automations you see in the Kubernetes space right now. There's also backups. So this is an area that support can help with. We have an article about how to do this. Obviously, you need to make sure that you have backup plans in place. In anything beyond just the most basic dev testing, you don't want to use the MongoDB that's just running on a pod, right? You want to have a standalone MongoDB instance, because as you increase traffic, you're just putting load on Kubernetes. The other thing is you're running a database in what is traditionally a transient resource, right? So while there are opportunities to make that stateful, just for enterprise instances especially, make sure that you're using standalone MongoDB or manage MongoDB through a service like Atlas, right? That brings us to identity management with groups. So I showed you where you can create different shared and managed spaces. So one of the parts of that is that you can associate groups with users and actually do group-based permissions to spaces. You can see an example here at the bottom of what this looks like, right, in the product. So QSEOK must be set up to accept these claims. In the console, there's a place where you can change this to automatically accept groups from the IDP. They're similar to session attributes in some ways in that they're sent from the IDP. They're stored for the user session, but they are cached by the system after successful login. And that cache will be what actually populates this filter list. These groups can be used in the assignment of shared and managed spaces. While Kubernetes provides the resources for high availability, it's not highly available without configuration. So you're not going to want to set up a one node cluster or a Minikube cluster for production. Some of the ways that you can consider making your system highly available are making sure that you have multiple nodes in different availability zones, right? Kubernetes can be configured to distribute pods between those environments. You want a horizontal pod autoscaler, or you want pod or at least pod replica set greater than one. And then you want to have backups and duplicates of mission critical services. So with that, because things can break, you're going to want to set up a logging platform for Qlik Sense Enterprise on Kubernetes. There is a demo available on help.qlik.com of just getting up Grafana and Prometheus set up very quickly. When you contact support, these are going to be some of the things that we're going to need from a troubleshooting perspective to understand if you're having performance issues, right? There are other options that are available, though. You don't have to use Grafana and Prometheus. Those are just the examples that are out there. Another really popular stack is the EFK stack. You're also, for any instance where there's going to be end users, you are going to want to set up a SSL certificate for the browser, right? So certificates are used throughout the product, but the most common place you're probably going to run into it at first is the ingress service. It can be configured by pointing to a TLS secret in Helm, which I have an example of in the lower right-hand corner of what that could look like. And don't worry, that's not my full certain key. These need to be in a PIM format. This is really easy to set up, and actually Christoph's video will show you how to do that as part of his setup. QSCOK doesn't support SSL offloading. So the SSL that you set in the ingress pod is largely going to be the SSL that your users see. Here are some resources. These are all of the references for the different versions of the conversations that we started today. I really hope that you guys enjoy the presentation. Additionally, here's the link to my Azure scripts and YAML files. Just remember, if you do want to set this up, please contact your account manager to talk with them about sign licensing possibly, but also to talk about services so that we can make sure that your QSCOK instance is going to meet your needs, right? This has covered a lot of the considerations that go into the product, but there's so much more to think about. So thanks for that, guys, and I guess we'll start the Q&A now.
Okay, everyone, now it's time for Q&A. Please enter your questions in the Q&A panel on the left side of your On24 console. Adam, which question would you like to address first?
So one of the questions that we got was, has this been tested in Google Cloud Services? It has. There are resources in help.qlik.com specific to Google Cloud, I believe, but we also are going to be adding information to that GitHub repository about doing the same thing that we just did in Microsoft Azure in Google Cloud, and talking about some of the net differences and some of the configurations you can make there. Let's go to another question. So one of the questions that we got was about limitations, specifically with Qlik Sense Mobile. To my knowledge, mobile is not supported with Qlik Sense Enterprise on Kubernetes. We can double check that. Obviously, you could go to a browser, but in terms of configuring it for mobile usage, I know that's a part of the plan, but I don't think that's out yet. The same thing is true of in-printing. We got another question asking if in-printing was supported to be run in Kubernetes. I don't think that in-printing would necessarily be set up to run in Kubernetes, but if you had an in-printing existing instance, right, on a Windows server, then it would be making sure that it could reach these engine pods in QlikSense Enterprise on Kubernetes, or that there was some way to ship that out. That's not currently available. Additionally, we do have support for geoanalytics through QlikSense Enterprise Enterprise on Kubernetes as of the September release. So that's the most stable release on Bintray that I showed during the demo. So let's look at some other questions. So I see a question, is it possible to use the traditional QMC to manage applications in Kubernetes? That's not possible. So the new cloud editions of QlikSense Enterprise use the new cloud editions of the hub and administrative console, right? And the reason for that is, as with mobile, as with QlikSense Enterprise for Windows, as you move to different contexts, it's the same analytic product, but the ways that you manage it are different and unique to those products, right? So one of the other questions is there an AMI for AWS deployments? Because a Kubernetes environment is necessarily, multiple servers and multiple services, I don't know that it would be just a Linux AMI running like a Minikube setup. I don't know if we'd ever do that. But what you may see is more things within the community, more things within blogs about using automation tooling like CloudFormation or other things to set up environments, right? So like with the GitHub that I created, there are going to be other resources that are to be created that will allow you to test different kinds of deployments. So one of the things I highlighted during the demo is that one of our consultants, Christoph Schwartz, actually did the exact same thing I did, except he recorded all of his steps and not just put them in a text document, right, with Azure. So I expect that you'll see more out there with that. So one of the other questions we got, it looks like, is does the ingress pod support Let's Encrypt? I can't think of any reason why it wouldn't. Some of the requirements are just that it's a valid third-party certificate, right, with the right subject alternative names associated with it. So if you can do that in Let's Encrypt, I'm not that familiar with it, but for the examples I've created before, I've used TinyCert, but again, that's not something you'd want to use in a production instance. One of the other questions that we got was, can applications be pinned to certain engine pods? I don't know if that behavior is currently in the product. I've not seen anything about that, but I would imagine that would be something that we would want to do. So I would keep an eye on that.
Okay, Adam, we have time for one last question.
So I think, the last question that I want to answer is, so what other IDPs are available? So I highlighted Auth0. Additionally, I know that Okta has been confirmed and Qlik has been confirmed. So those are three that have been tested, at least with Auth0 and Okta. Those are on the help.qlik.com, but Qlik would be another one that you would want to set up.
Thanks, guys.
Okay, great. Thank you, everyone. We hope you enjoyed this session. Thank you to Adam for presenting. We appreciate getting experts like Adam to share with us. Here's our legal disclaimer. Thank you once again, and have a great rest of your day.